Hi. Thank you for the introduction, and thank you to the scientific committee for inviting me to give this talk. I'm going to tell you a little bit about what my lab talks about as ATP release from the urothelium, and first of all, I have nothing to disclose. So if you've been coming to this meeting for the last 10, 15 years, I don't need to tell you how important urothelial ATP release is. There have been many talks about it. It wasn't until recently, though, that we've really started to take a look at the mechanisms behind the release from the urothelium. And it's turned out that there's actually two types of release, two main categories: the vesicular release, that classic vesicular release, as well as now we've found some non-vesicular mechanisms, including the pannexin channel, which my lab is interested in, as well as the connexin and calm channels. But it's not really known. We're not quite sure if activation of these ATP release mechanisms has different effects. Does ATP have the same effect no matter where it comes from, or why would the urothelium have more than one mechanism? And so that's what my lab has looked at here. The first goal that we've had for this is to determine if different stimuli can activate different mechanisms of ATP release from the urothelial cells. And to do this, we looked at two models. One, this nicotinic receptor-mediated ATP release that my lab has been looking at for quite some time now, where stimulation of alpha-3 nicotinic receptors causes the release of ATP, but also the classic cystitis kind of a stimuli with LPS, or the endotoxin mediated that sort of mimics bacterial infection. And so, interestingly enough, and this was quite a surprise to us in the lab, these two stimuli seem to activate different mechanisms. First, if you see on the top here, where we're stimulating with the alpha-3 nicotinic receptor agonist, we can get a large increase in ATP, which is blocked by brilliant blue FCF, which is a specific pannexin channel antagonist. On the bottom here, if we stimulate with LPS, we can again get that ATP release, but if we then put on the pannexin channel antagonist, brilliant blue, we actually get an increase in ATP release. Now this LPS is mediated ATP release is blocked by the destruction of lysosomes through the use of GPN, or this glyphenyl beta-naphthalamide. And that, then, if you go back up to the top, GPN has no effect on the nicotinic response. So these definitely, we've concluded that the urothelium has two distinct mechanisms which can be activated by different stimuli. The nicotinics mediate pannexin-mediated release, but LPS seems to be releasing ATP through a lysosomally mediated event. The second goal of this talk was to see if these distinct pathways also had distinct physiological effects. And so we first took a look at this in vitro bladder strips in the tissue bath. And you could see there on the left-hand side, cytosine, this alpha-3 nicotinic receptor, had no effect, even if we put it in concentrations that was 5 times larger than what we put in to get ATP release in cells. However, LPS, you can see there in the middle of that left panel, does have a large effect in increasing not only the basal detrusor contractility, but also or the basal tone, but also the contractility. And so that is blocked if we remove the urothelium, if we destroy ATP with a pyrase, if we block the lysosomes or destroy the lysosomes with GPN, or as well as if we put on a P2X7 antagonist or a COX inhibitor as well. Now, if we then take a look at in vivo rat cystometry, though, we know that a treatment with both of these agents, both the alpha-3 nicotinic agonist and LPS, can cause a significant decrease in the ICI, so a significant excitation of bladder reflexes in the anesthetized rat. So while both of these agents in vivo seem to be having an excitatory effect, it seems like this is being mediated by different pathways. And so just to conclude, the urothelial cells can release ATP by two different mechanisms: lysosomal release or via pannexin channels. These two mechanisms are differentially stimulated by two different pathways, either the nicotinic receptor agonist for the LPS, nicotinic for the pannexin release, or lysosomal release for the LPS. And so this suggests to us that the activation of both pathways, while they can increase bladder activity in vivo, they're different mechanisms. And so we hypothesized that LPS is inducing an inflammatory response based on that data where we've blocked the COX enzymes and the P2X7 receptor. However, the nicotinic, maybe this is inducing ATP release that directly is exciting bladder afferent nerves, since those afferent nerves don't exist in our bladder, in vitro bladder prep, but do exist, of course, in the in vivo prep. And so this might suggest that the mechanisms of urothelial ATP release, as well as the extracellular targets of ATP, might be markedly different under, say, physiological or pathophysiological conditions. So, thank you.
Any questions from the audience?
Thank you. Interesting. Chris Fry from Bristol. Many people get ATP released by stretching the tissue samples. And have you tried that, and do they have different sensitivities of stretch-activated release, or is that a silly question?
Yeah, that's a great question. We've actually taken a look at stretch previously in the rat model in vivo, actually, where we've stretched so we basically set the rat up like a cystometry, but collect the urine or the perfusate that's coming through it, and we can see that the stretch is mediated through pannexin channel events. We can stimulate it with LPS as well, and that pannexin knocks down the stretch-mediated event, but doesn't knock down all of the ATP release. It's still quite elevated. So it does seem that stretch seems to be going through the pannexin side of this and not the lysosomal.
Right. Interesting. Thanks.
Mm-hmm. Dave Plum, Northwestern. Have you tried other LPS preparations, and if not, what is the one you're using here?
This one here is the 011B4, I believe. We've tried other things. We've even tried some salmonella. We get varying results with it, even with the 011B4, which I believe is due to its preparation and quality control and getting from Sigma. We have some problems with that. But it does seem that the 011B4 is the best results that we've gotten so far.
Tom Chalimsky from Milwaukee. I missed the beginning of the talk, so I don't know if you said this or not, but cardiac mitochondria do have that exact nicotinic receptor in the mitochondria, which affects ATP release and production. And in fact, that's how. So, for example, if you have a rat model where you produce ischemia of the heart, you reduce the size of the infarct dramatically by either vagal stimulation or by direct cholinergic stimulation by binding to the mitochondrial receptors. I don't know if you were aware of that. And
I'm vaguely aware of the mitochondria. We haven't really taken a look at it. Most of the staining that we've been able to see seems to suggest that it's on the cell membrane, actually the apical membrane of the urothelial cells. So we haven't seen really the punctate staining that you would think that you would see in mitochondria.
Right.
But it's something we've thought about.
Thank you very much.